So last time we were looking at, and I'm like, different parts of the bone, a little bit about some of the bone cells, some of the functions of bones. Today we're going to look at how do bones develop, how do we maintain the bones, what happens if you break a bone. And so we're going to look, not just starting in cartilage, but, be like, oh yes, bones start off as cartilage. But we're going to look at actually what happens, when it starts from cartilage and goes to bone. So this whole process of making bone is called ossification or osteogenesis. Anything osteo means what? What a bone. Any guess what genesis means? It means making. Not that I'm going to get religious, but it's the first book of the Bible and everything's made. And I'm like, osteogenesis, it just means making bone. It's ossification. So it's the process of bone tissue formation. Now, the actual making of bone tissue versus cartilage tissue starts happening in the second month of development. So fetal development, by the second month, you're already laying down bone tissue versus just cartilage tissue. Now, postnatal bone growth, so after birth, you're going to have new bone being laid down, more bone being added until early adulthood. Do you remember about when all of your bones are done growing? Completely? 25, because your feet still grow for a while. And I'm like, bone remodeling and repair, that lasts for the entire life. We're constantly breaking old bone down, making new bone. That's a lifelong type of process. Now, there are two types of bone formation, ossification. There's endochondral ossification. What does the chondr part mean? It means cartilage. So this really is the cartilage turning into bone. So it's replacing hyaline cartilage, making bone from it. Now, we're not just taking cartilage and adding calcium. We do have to get rid of the cartilage and then lay bone down there. And I'm like, it's just cartilage starts first. We get rid of the cartilage, and then we actually lay down bone tissue. And so the bones that first start off as cartilage and then get removed and replaced, we call these cartilage bones, because that's what they started off as, or endochondral. Most of the bones in our body, started off as a cartilage, and then we get rid of the cartilage and turn bone. I say most of the bones of the skeleton, it's pretty much like skull down. Like all the bones are long, but it's mostly long bones. It's just some of the bones of our skull are really thin and flat. And they're part of what's known as the intramembranous ossification. Now, endochondral started off as cartilage. Intramembranous starts off as a fibrous membrane, where you've got fibers all over. And then we lay bone tissue down there. And so we call them membrane bones. These form our flat bones, most of our cranial bones, and I'm like, they are flat that encompass our skull, our brain that's in there, and then our clavicles as well are flat bones. And I'm like, these started off as a fibrous tissue versus cartilage and got laid down. And we'll look at what happens in all of this. There was my endochondral. Most bones, pretty much underneath the skull, except the clavicles, begin second month of development, and we start off as hyaline cartilage. We get rid of the hyaline cartilage before we lay down our new bone. Now, it's like my huge step-by-step, and you're like, that's awesome. Picture, because I like pictures. These steps coordinate with, these steps. I'm going to not write on my white thing today. It's gone. But I'm like, these steps, that's all wordy, is picture form, because I'm a picture person. So I like to see what is happening, so I may still go back and forth. But the very first things, we start off as cartilage. Everything blue on this picture is cartilage. So we have to start off as cartilage. That's the whole endochondral ossification. We start off as cartilage. Then what starts to happen is we start to get, it's called a bone collar. It just means we start laying bone down along the edges. When you think of a collar, it's like around the neck. For dogs, where the collar is around the neck, it's nice and narrow. Well, we're laying down bone down the narrower middle part. So we call it a bone collar. We also start to develop what's known as a primary ossification center. Okay, it's where we're going to start laying some more bone down. It's right in the middle. It's primary. It's like the beginning of bone. Now, the cartilage that's in this middle area of our bone, and I'm like, in the diaphysis, it starts to calcify. And I'm like, and we start to develop a cavity. What's this cavity called that's going to be right here? The medullary cavity. And so now we start forming an inner cavity inside of our bone/cartilage. Then we get a periosteal bud. Now, periosteum is a structure that goes around bone. This just means we have now a blood vessel that is going to go into this bone structure. It's going to try to go into this newly forming medullary cavity. And now we have blood supply in here. Before we didn't have any blood supply, any nutrients had to come from our surrounding tissues. But now we have blood going in, and I'm like, it's going to go into this medullary cavity, and it's going to start to spread downward and upward and start to form your spongy bone that you're going to see in these epiphyses. So we kind of start the middle, work our way out. It will continue to do that. However, that's a really long way to go. And so we start to get these secondary ossification centers in the epiphyses. That's like, okay, that's a really long way to go all the way up and all the way down. We'll just have 2 more blood vessels going into each epiphyses and lay down bone tissue up in either epiphyses. And this is where we're laying down even more spongy bone. Now, the epiphyses will start to harden. That cartilage will go away. The only place that you still find cartilage is right here. It's still blue. What is that called? That's your epiphyseal plate. And I'm like, where bones are going to continue to still lay down new tissue. We're still going to go from cartilage to bone in both of those epiphyseal plates. But I'm like, we're just slowly laying down, getting rid of cartilage, laying down new bone, kind of from the middle, the diaphysis, and then all the way out to the ends to make those spongy bone in the epiphyse regions. That's your endochondral. You know, I'm like, we're going from cartilage to bone. Now, the other type of ossification that starts out is that fibrous connective tissue. So now we start with the fibrous connective tissue. This is the one that forms most of the bones of the skull, nice flat ones. The cells that start this bone process off, we just start with fibrous connective tissue, no bone tissue whatsoever. There are some cells called mesenchymal cells. And again, I've got a picture that goes through these next steps as well. There's our fibrous tissue, all of my purple, and we can see little stringy purple fibers everywhere. I do have a pointer because I'm short. Then you're going to get these mesenchymal cells. Some of these runs around the outside that are going to be like, all right, we need to come together and start this off. And they're going to recruit some osteoblasts. And what do osteoblasts do? They're the building cells. And so these mesenchymal cells, they congregate together, they recruit some osteoblasts. And these osteoblasts, the bone building cells that are hanging out together, secrete a substance called osteoid. Now again, anything oste has to do with bone. It's an unmineralized matrix. That's the official word for it. It just means we're laying down some bone type tissue, but there's no calcium in it yet, so it's still kind of weak. So these osteoblasts are laying down this unmineralized matrix called osteoid. It will start to pick up calcium, calcify, and they'll continue to secrete more and more and more until you start to get, now we have new tissue, all of this tan tissue. This is all this new calcified matrix. Osteoblasts are still making more, and we start to get a few osteocytes as well. What do osteocytes do? They're just maintaining the bone. And so you'll get a couple of those trapped in there that become osteocytes, and they try to maintain what's there, currently there. And so we don't totally have bone yet, but we've got bone-ish type tissue. After we lay down this bone-ish-like tissue, this matrix, then we start to have blood vessels come in, because there's no blood vessels yet, bring in all their nutrients. And as the blood vessels come in, they sit there and try to snake through this bone-like tissue. As the blood vessels snake through it, they're now creating this spongy bone-like material. And this spongy bone type of structure is you have all these blood vessels going through that new tissue. It will harden like that. And I'm like, so as the blood vessels go through, blood vessels go through, they create this weird spongy something that looks like a worm was going all the way through it. It's blood vessels. So now we're getting a spongy bone looking like tissue. It will harden into official spongy bone. This will become all the trabeculae that makes up the rods of the spongy bone. But our skull is not spongy bone. We still have compact bone on the outside. And so some of our lamellar bone, part of our rods, will get replaced with compact bone on the outsides. And this is still right now what your bones look like. In your skull, if I sliced through them, you're going to see spongy bone on the inside, with all the little rods, the trabeculae, lots of blood supply, and you're going to see compact bone on the outside. There's no epiphyses, there's no diaphysis in the middle. It's just this middle area of spongy bone, and then there's compact bone on either side. And that's all of our skull. It just started off as fibrous tissue. There's no cartilage at all whatsoever getting laid down. Now, some developmental aspects of bones. Our skeleton ossifies. And I'm like, predictably. So you can do an x-ray of a fetus, and just by looking at what's happening bone-wise, they can make a predictable age and how many weeks they are, just by looking at it. Most long bones start ossifying. They start laying down bone tissue around week 8. You're going to start to see some primary ossification centers. Go back to primary ossification centers. You're going to start to see some of these in your long bones by week 12 fetus, and I'm like, so it barely looks like anything at this point. By the time they're bone, most long bones are ossified, except at the epiphyses, where you still have some spongy bone and you still have the epiphyseal plate. But yes, by age 25, all of your bones, including your feet, should be completely ossified. No more cartilage. Everything's fully made. Your bones aren't changing anymore. Here's an actual picture of a fetus at 12 weeks. Any place in the bones where you start to see some of the darker tissue, these are some of those ossification centers. And so I'm like, you can take an x-ray of a fetus and be like, look, bone is getting laid down in different parts of the body. And they can make a prediction week-wise, just based on that. But you can start to see them like, at 12 weeks, this is not all bone. And I'm like, it's starting to look like bone, but what is it? If it's not bone tissue, it's what tissue? It's cartilage. So this is all just a darker staining cartilage. And I'm like, but it's getting, by 12 weeks, it's starting to turn into bone tissue. Now, things that regulate your bone growth. Hormones. The main hormone that stimulates your bones to grow is your growth hormone. Makes sense. It's the one that stimulates your epiphyseal plate. Lay down new cartilage, lay down new bone. Now the thyroid hormone, it modulates, it kind of controls the activity of the growth hormone. So the growth hormone's main job is, let's just grow. But something has to keep it in check. And so thyroid hormone keeps it in check. So you don't make too much growth hormone or too little growth hormone. It ensures proper proportion. This is just showing them like, this is a child, they're both the same age. This one has growth hormone deficiency. There's not enough growth hormones. You won't grow as tall. Maybe that's what happened to me. I don't know. My parents are short too. Or if your thyroid hormone is not regulating your growth hormone and you have excessive amount of growth, then you get into the cases where you've got like the 9 feet tall person. They have that gigantism. And I'm like, where their bones just keep growing, like abnormally long. And I'm like unproportionately long. They should never be that long. But it's a hormone. Nothing was keeping that growth hormone in check. Now that I always have someone like, well, if you're this person and you have a growth hormone deficiency or your thyroid hormone's not regulating it, could you take growth hormones and grow taller? What do you think? You can. And I'm like, if they suspect that someone's not getting enough growth hormone and they try to track it early, I'm like, it's one of the things, and when they go to the doctor, they see how tall you are. I'm like, they realize like, oh my goodness, they are like significantly shorter than anyone that's in their age class. And definitely, if their parents are really tall, something's happening. It's probably a hormonal thing. They can give them growth hormones. Now, Could I take a growth hormone, grow taller? No. And I'm like, all my epiphyseal plates have closed. By the time you get to late adolescence, it's done. All your epiphyseal plates are closed. You're not laying down new bone growth. It'd be great if I could, but you can't. Other hormones that regulate it, testosterone in males and estrogen in females. These are your sex hormones. They're the ones that promote these adolescent growth spurts. And I'm like, so all of a sudden, you hit certain ages as you're growing up, and you get a whole bunch of hormones, whether it's estrogen or testosterone. And all of a sudden, you grow. You guys all have at some point, if you remember way back when, like middle school, and you're like, oh my God, there was like one summer I grew like 5 inches. Maybe your parents tell you these things you don't remember. And I'm like, at some point in that summer, you had a huge burst of testosterone or estrogen, and yes, that stimulated a whole bunch of bone growth, and you had a growth spurt. And I'm like, now, which hormone do you think kicks in sooner? Estrogen does. Estrogen kicks in sooner, which is why in the middle school age, the majority of the females middle school age are taller than the boys. A lot of times the testosterone doesn't kick in until like 8th grade, 9th grade, 10th grade even sometimes. And I'm like, and then, the boys get taller again, but that estrogen kicks in first. Which, because it kicks in first, it ends first, which means girls stop growing sooner than boys as well. If you have an excess or a deficit of any of these, you have abnormal bone growth. You grow too tall, or you don't grow tall enough. Now, maintaining bone. We recycle about 5 to 7% of our bone tissue or bone mass every week. So we are constantly breaking some down, reusing it somewhere, adding new tissue. They say our spongy bone is like completely brand new tissue about every 3 to 4 years. That will literally have gotten rid of everything. We don't reuse it. We just got rid of everything that was in your spongy bone and laid completely new spongy bone down about every 3 to 4 years. Compact bone, it's a little bit harder. It's compact. We replace our compact bone about every 10 years. We don't like old bones. We like new bones. So we like to have new bone tissue, breaking down the old stuff, making the new stuff. Because as your bones start to become older, they start to become more brittle. Those calcium salts crystallize. They can fracture easier. So we want to get rid of old bone, lay down new bone. And I'm like, and our bones are constantly doing that. So it's all of this bone remodeling, bone repair. Get rid of old, lay down new. Now, well, I'll go back to it, Mike. Which bone cell gets rid of the old? Osteoclasts, they break down, and which bone cells then lay down the new? Osteoblasts. Now, there are some things that can affect how fast this remodeling happens, and I'm like the activity of these osteoblasts and osteoclasts. Our bones grow or remodel in response to the demands we put on our bones. So not everyone's bones remodel at the same rate. It depends on what we do with our bones. It explains your handedness. If you are right-handed or left-handed, how many are left-handed in here? We've got like and I'm like, in your upper arm, if you are right-handed in your right arm,